recording. So we've missed a little bit right here. And this is just for a quick version. We've done a review, and now we're getting into the discussion of the Agile architecture, shall we say, the strategic parts right here. We're getting to the engineering aspect. We just went over the policies, capabilities, functions, versus how we get our information and what technology we're talking about in order to execute upon the business strategy. So let me just get back here. And now we're going to go into the pre-sprint activities. And this is known as emergent design. This is where once you start expanding and you have security champions involved, and you guys become the security champions as you start building out the teams, you become a lot more involved in this. As it is, you guys are going to collaborate on this. So I'm breaking up the lists of all the different emergent design activities into two parts, the pre-sprint activities and the in-sprint activities. And I've highlighted the ones that are in pre-sprint activities right here. So these pre-sprint activities, remember, it's an 80-20 rule. So you do as much as you need to, and then you move on. Don't get overwhelmed with anything right here, and don't worry about not covering the entire thing. You're trying to get as much coverage as possible with the time you have available to you. So let's start out with requirements and visioning. So requirements and visioning essentially means you take the business requirements or something like that, the equivalent right there, and you're going to find what the security requirements are from that. So, yesterday we did a bit of a mental exercise. If you have a user story, and the user story says, as an administrator, I want to have access to all files. Well, first of all, it's a very problematic statement, but can you guys tell me what stride elements you might think exist in that and where, as a mental exercise?
Elevation.
Okay, and what's the elevation?
Giving them access to all files, and that's they got they're already an admin, right?
Yeah.
So it's just giving them access to everything.
It's bad, I know, but that's a good point. Okay, next. Any other things you might say, Kyle?
Information disclosure.
Okay, and how's that?
Having access to all files that have information.
Yeah, I mean, so you guys get you get the point. And this is just in doing a small thing. I don't want to go any further on it, but I just wanted to show you this is how simple it is. It's really a discussion where you look at a user story or you look at an epic and you say, okay, based upon this epic, can we find anything in Stride that's relevant to it? You might find all elements of Stride, but try to keep it down to about 3 of the major elements like you did beforehand, and it focuses your efforts. And then you move on from there. Again, the 80-20 rule. That's the requirements and visioning. The next one is prioritizing those requirements. Now, we don't need to do any kind of special thing here if you guys want to go into depth. I know there are other companies who do, but essentially what it means is what do we backlog and what do we execute on, right? And you might have a tremendous amount of security requirements. You say, look, we can't get it all done. We can't get all the integration done. We're going to have to backlog this stuff because that's, we only have so much time available to us. So what are we going to backlog and what are we going to put in? How do we prioritize this? Architectural envisioning then is the next one. And now we're talking about like the initial architectural modeling during sprint 0. So that means when you're creating your epics, and you're getting the whole idea right there at the very beginning, or if you're already in motion and you want to develop something, then it's developing the architecture at that point in time, but a high level architecture. How does everything hang together? How does everything integrate? And once you get an understanding of that, then you can say, okay, that high level secure architecture, where are we going to find our pain points? Again, where you can use Stride to find these pain points out. Well, I mean, I think I've got a good chunk of the guys who are going to be developing this. So active stakeholder participation means you all need to participate. So on we go. Now, when I say single source of information, let's try to keep all of that security information as annotations on your stories or in your epics. Try to keep it all in the same ticket or try to keep it all in the same content area, okay? Try not to create separate security documents if you can. And then don't go crazy on writing up a bunch of security stuff. You want to keep these things lean and slim. And the single source of information means that you guys go to one location and you're going to find the entire story. You're going to find your security stuff. You're going to find everything there. It's easier that way, believe me. Otherwise, things get left to the wayside. We forget them. And then months later, you say, hey, did you guys do that TLS stuff? And then somebody goes, oh, yeah, shoot, I forgot, that kind of thing. And then this just barely good enough is a whole 80-20 bit. So you want to do enough to get you through. You don't want to go crazy and over-engineer anything. And that's kind of the whole Agile ethos, isn't it, anyways? So now we're going to talk about in-sprint activities. And that's the rest of these things you see right here. Okay. Start off with model storming. Model storming should take place very, very rapidly at the beginning of a sprint. It's essentially what it's doing is you're looking over the model you have and you're saying, are there any changes? Is there anything we missed? We need to do, move on. It should take a couple minutes of discussion. Test-driven design, the idea behind that is that you're creating you're creating your designs and you're creating your implementation and you're driving it by whether it breaks or not. That's threat modeling basically. So what threat modeling says is we're going to create threats and mitigations out of that, and then we're going to test to see if those mitigations have been put in the code, and we're going to test to see if we still have those threats. The testing for the threats is we do actual, security tests on them, whether they're automated or anything. The test for the mitigations is we run it through a secure, static code analyzer, and do things pop up that shouldn't pop up. Now, this is an interesting one. So executable specifications means that you want to do just-in-time tests, and it kind of flows back into test-driven design. And I had to look at this a few times. I had to think like, okay, what's the differentiation between these two things? And there isn't much differentiation between driving a test at the end of a sprint and executable specifications. It just means that you need to be able to enable yourself to create tests out of this. That's all. So if you can't create tests, then you have to go bubble down, if that makes any sense. You need to drill down a bit in order to create something where you can actually create tests out of it if it's too abstract. And then go in iterations. So you model, you do your sprint, then you say, okay, we need to add more information. You add more information, you remodel. This leads us to look ahead modeling. So look ahead modeling means you can do what if analysis. So the best thing about threat modeling is you can actually create copies, and you can run the copies in simulations in parallel. Like, what if we did this? What if we did that? What if this happened? And you can run it fairly quickly and get answers or get results out that you'd say, okay, this is what would happen if we did this. And this follows on. The document continuously is also just barely good enough because you want to put in that information in shorthand into the tickets or into the model verb like that. But you want to do it so you don't have to wait until the end of the sprint. You want to be adding that information continuously, which is strange because then we say document late. So don't do upfront documentation is what that means. You remember the bad old days. I don't know if anybody remembers the bad old days where you sit down. I remember them where you sit down and someone says, okay, I want you to write a ton of specifications before you even start with any kind of application development. And you're writing all the specifications, and then you write them in properly, and you spend a ton of time, and then they say, well, that's wrong. And you spend months doing it, and you never actually get to the job you're supposed to be doing, which is creating code. Multiple models flies back to look ahead modeling. So multiple models basically says, again, it's what if analysis. And multiple models can be done on threat actors. If you're talking about critical components, different attack scenarios you can change, strategies, and different security patterns. What if we apply this security pattern? Again, it's what if modeling right here. And now I'm going to drill into the sprint activities. So I'm going to take those previous bubbles and I'm going to put it into something a bit more iterative right here. So the requirements envisioning right here, that comes down, that's a sprint zero activity. Okay, so with requirements envisioning, we say, okay, we get our business requirements and we get our security requirements off of those. Shouldn't take that long. It's going to take a few days for you to discuss the business requirements and then add the security requirements into it. The initial architecture envisioning comes off of that. So once you say we have our requirements, how are we going to go about executing those from a higher level? What patterns are we going to put in? What frameworks are we going to add? And what security frameworks are we going to add to that? Again, based upon your threat model. Once we get into each sprint, and each sprint is bounded right here, each development sprint called iterations in this. We have the iteration modeling. Now you take a look at the arrows right here. So iteration modeling leads to model storming, and then back and forth between the test-driven development. Makes sense, right? So the iteration modeling, what we do is we say, okay, we're gonna spend a bit of time to pull out what we're actually going to do in the sprint to implement those security controls. So a security control, again, I use TLS. How are we going to go about implementing TLS? Oh, we'll just pull in this TLS library and we'll put it that way. And that's kind of the execution bit of it. The model storming says we have changes in the last minute. So before your sprint start, you want to just go over and make sure that everything's correct. And then it goes back and forth to the test-driven development. So, you know, you reinforce that. That's the rinse repeat bit right there. Is if it fails, you go back and you retest until you finally get it right. And that right there will come down to your different automated tools. So your SaaS tools, your DAS tools will give you feedback, and then plus also feedback from people in the sprints. So are there any questions on that, on any of this right here? And is there anything you feel you can add to your, like I gave a generic setup right here, but can anyone give me feedback on how they feel they can add this to their plans?
We tend to work in quite an iterative manner. So I imagine what we'll do is we'll kind of recap this stuff and then work out where the various kind of elements could fit into our process. So we don't run conventional sprints. We used to. It didn't work great for us. Our burn down chart always kind of looked like a square. So we kind of run to a Kanban, and we've got a kind of, so I imagine, like I say, we'll pick a part of this, work out how to build it, and test it, see if it works for us. Then move to the next part, work out where that fits. So it'd be having those kind of, if you like, those steps that need to be completed, and then we'll work out where those fit and how best to fit them in.
Yeah,
but
so
I really like the idea of putting them in the story, if that makes sense.
Yeah, if we go back to this right here, it's how to plug these in where you see the best fit is.
Yeah.
And then some of the stuff
totally
is abstract. Oh, sorry, I interrupted somebody.
No, I just said totally. Yeah.
Yeah, and that's and obviously with a Kanban, you're going to do it slightly different from what I showed you, which is Agile right here. But the ideas are very similar. You know, you're gonna get in there. You're gonna do a lot of, like when I say a lot of discussion, you're gonna do discussion, but they're gonna be very short discussion periods, and you're just gonna make sure you're aligned essentially. And remember, the main thing right here too is that you don't want to get overwhelming. And this is what I showed people when you guys actually do your threat model. Don't go overboard in explanations. If you guys understand shorthand, then do it and move on. Okay, your purpose is to get the mitigations and get those mitigations as controls in the code as opposed to fixes. That's the big thing. I have some hissing happening in the background. Is that Michael? Oh, sorry. Okay, white noise. Okay, so now we're going to talk about the attack kill chain and zones of trust. We went over this beforehand. Now we're pulling these two concepts together. The attack kill chain, we said, or I said that I thought the privilege escalation was the big nasty one, because that's where you can do lateral movement, and that's where all sorts of badness can happen. Anything up to there is bad, but step 5 is really bad, and step 6 is beyond bad at that point. Step 6 is your BA.com. You guys heard about that, I think 2018, where the BA.com payment page got infected by rogue JavaScript. And for 3 months, the bad guys collected all the payment data, siphoned it off, and sent it off in guise of, what was it? They sent it off and they made it look like it was auditing reports. But the problem was the URL they sent it off to, they found out afterwards when they did forensics, was someplace in Moldova. And that place in Moldova then bounced to a place in Russia and disappeared. So, yes, pretty bad stuff. Russia or Ukraine, I forget which, but it went off and it disappeared. And I warned my wife about it because she had used her American Express card to pay for her dad to come over here from Germany. And I said, you better shut that card down and get a new card. And she did. And a couple months later, American Express contacted her and said, look, somebody in Bangladesh tried to pull out 400,000 rupees on your card. But of course, the card was canceled. So, you know, that just shows like a real world situation that happened from that whole situation. And that was a pure privilege escalation because, first of all, whatever code it was injecting there should have been injected in the first place. So somehow you had a failure where they were allowed to inject the code. Second of all, the code is allowed to run, and it was elevated code, and it was allowed to send information outside of BA, which is another big no-no. There's privilege escalation all over the place with that. And they had to go back to the drawing board. Nobody ever talked about how that code got into BA. There were a lot of discussions, and it's interesting to me because sometimes you'll read stories, and I encourage you guys to do this. Like, go to the register, for example. I read register.com all the time. Go to the register and read some security stories, and they tell you this stuff, and they say, blah, blah, got hacked. And then your first question is, how? Sometimes they tell you, most of the times they won't, because it's usually too embarrassing for the company. With BA, it was that case. I think it was an insider job with BA. I really do, because I don't know how else they would have gotten the code in. I do know at Capital One, you remember the Capital One hack, that it was a disgruntled engineer who happened to be a consultant who had a beef against capitalism, I think. This is a hacktivist, pure hacktivist. And this person was given the keys to the castle of AWS. Funny enough, bad things happened. This person got access to, I think, a couple of the queues and messed with the queues, and then messed with a NoSQL database that was sitting behind with Capital One and caused all sorts of havoc before they found out. So, word to the wise, it's like, you got to make sure, again, about privilege escalation, about maintaining privilege, and about minimizing access to things in AWS. We discussed all this yesterday, and you guys understand it. So what did they say? Teaching you guys how to suck eggs. Is that the term? Right?
Yeah, I think so.
You guys how to suck eggs. I love that term. It doesn't mean anything to me as an American, but it's a great term. So
it doesn't mean a lot to me as a Brit either. So
well, I sit there and think, okay, maybe in the Middle Ages you like to suck eggs, but today I cook them. So anyways, all right, so we carry on to zone. Now, in the idea of doing zones of trust, you're going to look for changes in zones, and the changes in zones is where you can get the privilege escalation. So helpfully, again, I've provided you with color coding. So anytime the color code changes is potentially where you're going to have privilege escalation issues. Some of them are going to be more difficult than others. Where my cursor is right here, it'd be kind of difficult for a bad guy to get inside and attack this right here to product API. I'm not saying impossible, but it's a hell of a lot easier for them to attack this. So your primary focus point is anywhere where that external information comes in, or external endpoints are coming in. Then it gets progressively more difficult, not saying impossible, but more difficult. And a lot of times what the bad guys try to do is they try to find ways of going from here directly to here. So these being the keys to the castle, what a lot of people forget is, how do we go about protecting these, the identity stores, for example, or anything like that? They say, oh, it's completely internal. And so they leave the APIs open, that kind of thing. So let's talk about Rtmp. We got about 5 minutes to do the introduction to it. And then I'm going to, 7 minutes. And then I'm going to leave you guys for about a half an hour, and then we'll come back. Does that work? So Rtmp, Rapid Threat Model Prototyping. Remember I talked to you about identifying the nodes. You're going to do that same activity. So you're going to identify what nodes, what logical processes or whatever that you're talking about for your particular system. Now be specific here, guys. Don't, if you talk about the entire system, you're going to get a very general approach. If you talk about a specific, system that you want to code, then you're going to get a lot more specific controls for it. It's that easy. So in this particular one, as we know, it was a website that we discussed, and it had vaguely something to do with products and stuff like that. And it's very generic in that sense, and it does a lot of identification. So you want to identify what your microservices are, your subsystems, or anything like that. You want to identify your flows. So you want to identify your primary flows, where it goes from, where it goes to. As I said, your request response is the easiest way to figure that one. Request is usually your more dangerous flow than a response. Although they're both fairly dangerous for the bad guy to get a hold of, the request is more dangerous. And in this case right here, the request is the one where the bad guy or the malicious party can corrupt more easily. And then we go to the zones of criticality. So the zones of criticality, as you notice, I've now added numbers to this. This helps us out. It also will help us to move forward, making things faster. It's a lot easier to do numbers than it is colors. So let's walk through this. Let's see if this is a walking through this. Not in control of the system. So can anyone tell me what not in control of the system would mean for you guys with any generic endpoints?
Oh, just someone using one of our bots, like the communication we get. So someone, they type in hi, you know, that.
Yep, exactly.
External actors.
What sorry, Andrew, what was that?
External actors, so like anybody interacting with the system that doesn't have any control.
Yep. What about internal actors?
Employees can be, well, even us, sometimes developers, anybody that has access. If
Because,
you want
yeah.
to go that far, yeah.
And we did talk about the fact that, you know, people make unintentional threat actors. So that's another thing too. Just to add to all the list of woes you have. Now the next one is the boundary, and I call it external communication. Remember, it's external to the system you're modeling. So boundary objects, can you guys give me some ideas of some boundary objects that you guys have?
Our CMS
Okay.
and our webhooks.
Yep.
We have an API as well.
Yeah.
Proxy.
You have a web page, a website.
Website, yeah.
I don't know how much. I mean, the website looks like it's fairly sealed. I don't think, you know.
It's standalone.
Yeah. So, you know, they're not going to get much out of that, but it is an external endpoint. Okay. Next, we have low trust. So low trust objects, data effectively passes through. It does a minimum amount of processing and it gets passed through to something else. So what would you think of, like, you know, I have login, registration, anonymization. What would you guys think of would be low trust objects or examples of? You can be very generic with me, believe me. I don't want you to be specific.
It'd be similar to this, I think. Login and registration we obviously have. And I think the key here is, when you first asked this, I thought, what? And then I think it's not just, it's subcomponents of systems as well as systems, right? So where we're saying the CMS, this would be a subcomponent of the CMS.
Yes.
Your login and registration.
Yes.
Sorry.
Sorry.
Yeah. No, sorry, carry on. I'll say after this way. Sorry.
No, go for it.
I was going to say you could also have invitations. So like you could have unintentional threat agents as well from current current customers that are inviting their own employees to the system that then have access to those subcomponents.
Yep.
So log admins, right?
Yeah.
It can be fairly complicated, and it's not necessarily a simple thing of like a login subroutine or something like that, or an API endpoint or an API gateway or anything like that. So, gentlemen, I have about 4 minutes to go. 4 minutes to go right here. So, if it's okay with you, I'm gonna cut short, and then I'll come back again, and then we'll come back and then we'll carry on from there. Thank you for your patience.
No worries.
We'll see you soon.
Cheers.